And we're back with phospholipids, our second group, excuse me, our second group within the lipid category. In a phospholipid, what we have are two fatty acids and a phosphate group, and they are attached to a glycerol. So two fatty acid tails are hydrophobic. The phosphate group and its attachment form a hydrophilic head. Okay, so I've got these polar heads. Remember, we're talking about covalent bonds. So I have these polar heads, and I have these non-polar fatty acid tails. So where we're going to see the phospholipids play a huge role for us in biology is here in this structure right here. This is a cell membrane, and we have a phospholipid bilayer, but I'm getting ahead of myself. So let's back up just a little bit. Let's come back up here. When phospholipids are added to water, they do a sort of self-assembly or a rearrangement. And what they do is they form into a bilayer. Okay? All of the hydrophobic tails will point toward one another, toward an interior, and all of those polar heads or hydrophilic heads that are polar, if you prefer, will form an outer shell around those hydrophobic tails, those fatty acid tails. When it forms into a round structure, we call it a micelle. That'll be important in Biology 202 when you talk about digestion and bile salts. But again, I'm way ahead of myself. The structure of those phospholipids, that diversity, the polar heads and the non-polar tails, will really give them this bilayer arrangement that we find in the cell membranes. Just like in the micelle, the hydrophobic tails will kind of congregate together. I often think of these as like a sandwich, and the polar heads being out here, right, a lot near the water surfaces, either the interstitial fluid outside of the cell and the cytosol within the cell, and these phospholipid bilayers are really the major component of cell membranes. They're going to play a major role in transportation across those membranes. So we really need to grasp this bipolar, this bilayer, this bipolar nature of the phospholipid bilayer. I can't remember if it's in a slide coming up. I'm going to mention a term right now. It's called amphipathic. AMPHIPATHIC, amphipathic. And that's a term that we use to describe those molecules that are both hydrophobic and hydrophilic. So I'm hoping it pops up on another slide, but if not, it's absolutely in your textbook. So remember, we need to summarize some lipid knowledge that we've gained, right? So lipids have repeating subunits of carbons with two hydrogens. They can occur as triglycerides. That was that fatty acid that we looked at. They can form as or occur as phospholipids as in a bilayer. They can form as steroids. We call them hydrocarbons because they're composed predominantly of hydrogen and carbon. Lipids are themselves non-polar. They're hydrophobic. We store primarily as triglycerides. A triglyceride, remember, was composed of a glycerol backbone and three fatty acids attached to it. And remember, these guys are very energy dense. Whereas we'll get 4 calories per gram of carb, we're going to get double that, more than double that. We're going to get 9 calories per gram in the lipid category, right? So remember that bilayer structure, that self-assembly that we see in phospholipids is going to come in an aqueous environment. So again, the whiteboard's for my in-class, or if you're playing along online, you want to be able to draw a phospholipid. You want to label its parts, its polar head, its non-polar tails. You want to be able to put it into a bilayer and then label the hydrophobic and hydrophilic regions. And that's going to bring us up next to proteins. So I'm going to go ahead and break here right at 5 minutes, and we'll come back and talk about proteins.